Hi, I'm going to do two more quick examples for us, and then we'll be set to go with this lecture, I believe. And so let's see how it works, and I'm going to pick up and do the other two examples in class on Monday. Okay, so what do we see here? Here we have to deal with that first step of getting a 0 on one side of the inequality. So that means I have to subtract 2. Okay, so I do that. And then I have to take the second key step, which is to write it with a common denominator. So I'm going to put it over 1. I see that my denominator will be 2x minus 5. 6 is good, it's over that denominator. 2 I have to multiply by 2x minus 5. Just like we've done before, that's nothing new here. I have to multiply top and bottom by 2x minus 5. Okay, and that is less than or equal to 0. So that gives me the inequality, that's 6 minus 4x plus 10. Okay, so what do I have? 16 minus 4x and 2x minus 5. Okay, so again, refocus that for us. Okay. Now, what do? Well, now it's the same old routine. So I'm going to let f of x be that rational function. Okay, and so the next step is to find its zeros. Zeros of the numerator, of course 16 minus 4x equals 0, and we can see that x will be 4. Okay, and so we're good with that. Zeros of denominator. Set the denominator equal to 0. And we get x equals 5 halves. Okay, and 5 halves is not in the domain. And so it could not be an answer. But it is a possible change. It is an endpoint that we could be working with. Okay, so same old routine. Set up our number line. And we have the values of 5 halves and 4 for our f of x, which is 16 minus 4x over 2x minus 5. Now let's step back and make sure we have the overview here. Okay, we first of all had to get 0 on one side of the inequality. We write it as a single fraction, and then we look at the zeros of the numerator and denominator, those critical points. And then we set them on the number line to determine the sign of that function on each of those intervals. So what are the intervals that we're looking at? Again, we're looking at up to 5 halves to 4, and greater than 4. Okay, so let's use our trial points. 0. Let's see, 5 halves is 2.5, so how about 3? And 5. And again, we will plug in to find out. F of 0 is 16 minus 4 times 0 over 2 times 0 plus 5. 16 over 5, it's greater than 0. So it's positive on that interval up to 5 halves. Okay, between 5 halves and 4, our trial point is x equals 3. Plug 3 into the function. Okay, and what do we get? 16 minus 12 is 4 over 12 minus 5. Oh, I'm sorry. Whoa. That was 2x minus 5. That first one was negative, less than 0. Sorry about that. That should be negative. Okay, 2x minus 5. Here it's 2x minus 5, so it's 4 over 12 minus 5, which is 7. This one's positive. Sorry about that. That illustrates really the hardest part of these is just making sure that all those details are right. Let me cross that out completely. So watch that. Watch the double take. Now, I kind of knew that something was wrong because my roots, my zeros, they're factors of single multiplicity. So I expect a sign change. So when I didn't get it, I realized I had done something wrong, and I've just transcribed or mistranscribed the minus. Okay, 5. So then I get 16 minus 4 times 5 over 2 times 5 minus 5. And that is what? 16 minus 20, negative 4 over 5. Again, it's less than 0. Just what we expect. Okay, do you see what I'm saying? Each of my factors of f of x are raised to the first power. So we do expect a sign change at each of those critical numbers. Okay, so now what's our answer? Okay. And we want f of x to be less than or equal to 0. Remember, this is the inequality that we're solving once we've taken care of the rewriting it. Okay, so that's the one we're working at. We want to know where it's negative. So it looks like it's minus infinity to 5/2 and 4 to infinity. Now here we have to determine the endpoints, which are included. And notice we have an equal sign here. So what about 5/2? Remember that was a 0 from the denominator. Can't be in the domain, so it can't be included. But this time we're allowing 0 for the value of f of x. So if x is 4, we get 0. Over a non-zero value, we get the fraction having a value of 0. So that is a solution, and that's our inequality. Now, one thing that you might be tempted to do, you might say back here, can't I just multiply both sides by 2x minus 5? That's what we do with equations. The problem is inequalities have sign changes, okay? Think of 6 over 2x minus 5 being less than or equal to 2. What if, and sorry, I'll move it up so you can see it. Okay. If, just focus one more time. If x equals 2, we have 6 over 2x minus 5, what? 6 over negative 4 minus 5, 6 over negative 1. If we're going to multiply by negative 1, we have to flip the inequality. On the other hand, if x equals 5, I have 6 over 5. I don't flip the inequality. Okay, that's the problem. Depending on your x value, you may or may not be multiplying both sides by a negative number when you clear of fractions. And so we can't do it. That's why we have to get a 0 on one side of the equation. I hope that makes sense to you. It's all because we know when we multiply or divide by a negative number, we would have to flip the inequality. Okay? If we multiply by negative 1. But here we wouldn't, so we have ambiguity, and that's why we can't clear the fractions. Okay, I think we'll stop there for the evening. Let me just look at one more quick example and at least set it up for you, and then we will, you can go from there. Okay, we want to find the domain of this function. So I'm now on page 9 of the notes. Okay. And f of x is the square root, and I want to find its domain. What do I know about radicals? What's under the radical has to be what? At least 0. So I know that this quantity has to be greater than or equal to 0. And I'm going to give that a different name because the original function is f of x. We're just looking at the inside, so I'll call it g of x. Okay? And that has to be at least 0 in order to be in the domain. So that's the inequality that we solve and will tell us the domain of the original function. Okay? So to solve that inequality, first of all, we find the zeros. And also places where g of x is undefined. So numerator and denominator of our new function g of x. Okay, so the usual routine. We set the numerator equal to 0, and that factors so x equals 4 or x equals negative 2. Those are the zeros of the numerator. Now, what about the denominator? Here we have x squared plus 1 equals 0. And does that factor? Not in the real number system, and remember we're working with real numbers. If you try and solve that, you get x squared equals negative 1, which has no real solutions. Complex, yes, but real solutions, no. So it does not factor in the reals. And you can see where that, remember when you get x squared plus 1 in the denominator, you're not going to have factoring. So what is the domain of g of x? The domain of g of x is really all real numbers, if we just look at g of x without the square root. Okay, so then we set up our number line, but we only have 2 values to worry about. We only have negative 2 and 4. Okay, and we're looking at g of x, which is x minus 4, x plus 2, all over x squared plus 1. And we want to find its sign. Okay, so usual routine. This will be what? Negative 3, 0, and 5 for our trial points. And we know that the denominator is always positive, so we really could ignore it. But I'll go ahead and put it in just for completeness. Any shortcuts that you find that work, that's the proviso, that work, you're welcome to use to get the signs. Just be very careful. So I get negative 7 times negative 1, and it's positive, what, 10? Okay. And so what happens there is that that is greater than 0. And again, don't work it out. I just observe that it's positive. All right, if I plug in 0, 0 minus 4 times 0 plus 2 over 0 squared plus 1. That's negative 4 times 2 over 1. That's less than 0. And finally, 5. We can guess correctly that that's greater than 0. Okay? Now, what's the question that we're answering here? We're looking for the domain of f. And that occurs where our function g of x, the function we named g of x, this one, is greater than or equal to 0. And remember, we can allow 0. Okay? So we look at it. Where is it positive? Up to -2, and from 4 to infinity. Now the question is, do I include either of the endpoints? What do you think? They're in the numerator. They make the fraction equal to 0. Denominator's always positive, so we've got our domain. Okay, I hope that helps as you prepare for this lecture. You will see an inequality like this, some type of inequality on the exam. So good luck in your studying. I've posted the review sheet, so go for it, and we'll see you on Monday. Thanks.